let you ask now.
Good afternoon to all. Am I audible now?
Yeah.
Yes, sir.
Okay. Today I am going to discuss regarding a mobile overview of mobile network and evolution from first generation to fifth generation. Okay. Just brief introduction. The contents are mobile communication. Then we will discuss the driving force of 5G deployment and some 5G use cases. Okay. And how the from first generation to second generation and third generation, how 3GPP standardization progress done in from 3G to 5G. Okay, this slide is the basic. What is the communication? Right. Just a definition, that is the communication is the process of information exchange, information exchange and transmission between people or between people or between the things, on between the people and things, like that. The evolution of telecommunication started from telegraph. After
Sir, I
the
think
telegraph,
PPT is on the first slide still.
still on the first slide. Okay. Now, evolution of telecommunication.
Yes, sir.
Yes, sir.
Okay. The first evolution of telegraph, that was the first communication tool in the human history to transmit information using electricity, or you can say telephones. Followed soon after that telephones, landlines, little evolution done. After that evolution of landline, pager comes. After pager, that is the mobile phone. All of you know that these mobile phones, second generation and third generation. Now a smart mobile phones comes 4G and 5G. Right? These are the some media, modern communication media, optical fiber, network cables, Ethernet cables, and these wireless communication media, that is electromagnetic wave communication. Now slide is changing, na?
Yes, sir.
Yes, sir.
Okay. The characteristic of electromagnetic spectrum. All of you know, low frequency resources are very limited. Okay. And if you want to give more and more spectrum, then you have to go in the larger spectrum side, like infrared, visible red, or microwave. Okay. So these are the some frequency band written here. UHF, ultra high frequency, that range from 300 megahertz to 3000 megahertz. And SHF range is the 3 gigahertz to 30 gigahertz. This UHF is also known as the decimeter wave, and SHF is also known as centimeter wave. Right? And another one is the EHF, that is the 30 gigahertz to 300 gigahertz. It also known as the millimeter wave, because all these, the wavelength is in the comparable of millimeter. That's why millimeter wave, centimeter wave, and meter wave. And this millimeter wave and centimeter wave basically used in the our mobile communication. UHF, SHF, and EHF. All these waves, all these spectrum, you can say, nowadays used in the wireless communication system, either 2G or 3G, 4G or 5G. Different applications of radio communication. You can see here the aviation and navigation, the very low frequency, that is the 3 kilohertz to 300 kilohertz. These electromagnetic wave frequency that is used in this applications, aviation and navigation. And medium frequency, that is 300 kilohertz to 3 megahertz, that is used in the radio broadcasting stations. and high frequency used in the like Bluetooth and NFC types of tools. Then very high frequency 30 megahertz to 300 megahertz used in the wireless television and walkie-talkie. Now you can see 2G, 3G, 4G use frequencies from 300 megahertz to 3 gigahertz. That is the UHF range. Right. 5G actually use this UHF and SHF and EHF, not more SHF, but UHF and SHF and EHF. All these three bands are used in 5G communication. Right. And this EHF is known as millimeter wave spectrum. SHF is known as decimeter, centimeter, not decimeter. UHF is known as decimeter. Right. Now, these are the years when the your wireless communication standard starts. First generation in 1980. That was purely analog communications, right? Name of that communication system is the AMPS, TSCS, analog mobile phone system, like that. Okay, that was the purely analog communication, and only one types of service supported by first generation. That is voice service supported by first generation. Now, after 10 years in approximate 1990, second generation comes. That means that was the digital communication. Second generation is also running at that time also. Digital communication, GSM and CDMA, two basic technology that is used in the second generation. It is used for voice communication as well as SMS, right? Voice and SMS. In between 2G and 3G, some data also comes like 2.5G and 2.75G. That is GPRS and Edge. All of you might be using like Edge somewhere in 2G network area. So GPRS means General Packet Radio Service, right? That is 2.5G, and Edge is the 2.75G. Just evolution in the radio modulation techniques from GMSK to 8PSK. Then around 2000, third generation communication comes. The SS method used in third generation is WCDMA, right? WCDMA means wide band code division multiple access, right? And 2G generation, the radio access technique is the TDMA, and first generation radio access technique is the FDMA, frequency division multiple access. The TDMA cannot be used in first generation. Why? Because first generation was analog communication. TDMA can be used only in the digital communication. That's why TDMA comes from the second generation communication. We cannot use TDMA in the first generation. So SS method, basically what is the SS method? How the radio resource are allocated to different users, different mobile users. Okay, different subscribers. Then after 3G, are several actually between 3G and 4G, that is not a single evolution. There are different steps, 4 or 5 steps of evolution from 3G to 4G, right? And the 4G totally based on the our new next generation wireless communication, that the SS method used, and downlink direction is the orthogonal frequency division multiple access. And in uplink, all of you know what is the downlink and what is the uplink. Downlink means what your base station, what your BS transmitted on which frequency, and uplink means what your mobile phone transmitted, in which frequency your mobile station is transmitted, that is the uplink. And downlink means when your base station is transmitted on any frequency, that is the downlink. Okay, so in the first generation, second generation, third generation, your uplink and downlink access methods are same, right? But in 4G, downlink access method is the OFDMA and uplink method is different, that is SCFDMA. SCFDMA, right? And the 4G technology basically known as the LTE Advance, and the peak data rate is the 100 Mbps in the 20 megahertz bandwidth spectrum. Okay, and 5G now evolution, that is the 10 to 20 gigabits per second throughput, peak throughput, 10 gigabits per second in the uplink and 20 gigabits per second in the downlink, and 1 millisecond latency should be there in the 5G communication. And third one is the 1 million devices per kilometer square. That is the connection density in the 5G communication system is much more and more than the previous generation, much higher than the third generation and fourth generation. Right? A number of applications can be deployed in the 5G communication. That types of application is not available in previous communications. Now this slide shows the general architecture of mobile communication network. This one is your terminal mobile devices connected. That interface is the wireless interface, air interface. Okay, that is the connected with the base station. Okay, 4G, 5G that have only one types of base station. In the radio access network, that is the your 3G base station is known as the node B, right? Your 4G station is known as the E node B, evolved node B, and 5G base station is known as G node B, next generation node B, G node. Okay, so your wireless terminal is connected with the base station, and base station is connected with the direct core network. In 4G, core network is known as the EPC, and 5G, the core network is known as the 5GC. Right? In between, connection between radio access network and core network, that is known as the transport network or a backhaul. Okay? And these are the different applications. Third-party applications can be communicated via this mobile to this from this mobile network. Third-party applications can be accessed by terminal via this network, 5G network or 4G network. Okay, 5G having very large number of third-party application capable of large number of wireless or application services capable, but your fourth generation and third generation having very limited third-party applications accessibility. Okay, so LT and RU, you can see here the different base station. LT base station, LT means 4G base station, radio access network, that is the long-term evolution. The RAN of 4G is also known as the LT, radio access network, and 5G radio access is known as NR, that is the new radio. And core network, two main parts of any mobile network, that is the access network and core network. Right? Access network having base station and core network having different intelligence, or you can say different authentication, all these main decision taking capability having this core network. Okay, a connectivity between these things are the transport network, or you can say backhaul. Initially here you can see here na, LT and NR both are connected with the same core network, right? 4G and 5G base station are connected with the same network, same core network. This core network may be 4G core network or maybe 5G core network. When your 4G and 5G base station connected with the 4G core network, This types of deployment is known as the non-standalone deployment. This deployment actually basically it is a faster deployment option to the operator, right? Because only they are adding only the base station at the BTS side, na? And just by some software application they can deploy the service of 5G in the network, right? This is the fastest deployment option, very quick, and also it is a very cost effective deployment option. Okay, but when your 5G base station and also 4G base station connected with the 5G core, that is the not a cost effective. It is involved a time also, and also it involves the cost, but it is applicable for, or you can say useful for different use cases, different applications. Non NSA non-standalone deployment option have only limited capability like EMBB, but your standalone deployment options having all the capability of 5G, all the capability of 5G. So three main capability EMBB might be here, na? Enhanced mobile broadband and URLLC. These are the different use cases of 5G. URLLC and EMBB, URLLC, MMTC. So, EMBB supported in NSA mode, non-standalone. That means your core network is of 4G. Okay, when you are deploy 5G core and 5G base station, all the use cases means EMBB, URLLC, and MMTC supported by your SA network. So initially, any operator may deploy an SA. After that, they deploy SA. Okay. Why an SA? Because of it is a faster deployment option and also cost-effective deployment option. Okay. Now one question is there: which of the following frequency band is mainstream 2G, 4G frequency band? Can anyone told me or submit the answer in the chat box? Medium frequency, high frequency, VHF and UHF. Which of the following frequency band is the mainstream of 2G, 3G, 4G, 5G? Am I audible to all or not?
Yes, sir.
Yes, sir.
Please tell me which option is correct. A, B, C, D. Most of you give the answer B, B, C, D. The mainstream of second generation, third generation, and fourth generation, and also with fifth generation, not B and C or A. Okay, that is the UHF. That is correct answer is UHF, ultra high frequency. That is the 300 megahertz to 3 gigahertz. That is the mainstream frequency band. Only one answer is correct. That is given by Ziaul Islam. All others are incorrect answer. Okay. Mainstream is from 300 megahertz to 3 gigahertz. Lower frequency are not using in the this mobile communication 2G, 3G, and 4G, 5G. Okay.
Yes, sir.
Now, what are the vision of 5G? Because in 5G will have profound impact on various fields. Okay, different types of field you can see here: industrial, agriculture, healthcare, education, transportation, finance, environment, cloud office, augmented reality, virtual reality, okay, mobile terminal, industry, smart home, okay. It impacts on the various fields, society, providing a flexible and adaptable service experience for different users and scenario. Okay, 5G comes previously your fourth generation, third generation, basically a human-centric communication, human-centric, na? But 5G is a machine-centric or device-centric communication, right? These are the International Telecommunication Union 5G vision. 5G official name of 5G is known as the IMT 2020. Okay, what is the full form of IMT? That is the International Mobile Telecommunication. 2020 is the just a year, right? And what is the official name of 3G? Official name of 3G is the IMT 2000, right? And what is the official name of 4G? IMT Advance, right? These are the just official name in the dictionary of ITU, right? These are the three use cases, na? Enhanced mobile broadband and MMTC and URLLC. These are the three main use cases specified by 3GPP. Actually, these standards are specified by 3GPP. The main first EMBB, that is the more and more throughput, enhanced mobile broadband. First domain, or you can say first evolution, second evolution is the MMTC, that is the 1 million connection per kilometer square. That means connection density is more and more in 5G. And third domain is the ultra reliable low latency communications, where latency should be very low, where real time all the real time applications comes under this ultra reliable low latency communication, just like a driverless car, okay, and tactile internet, all the different applications where required very low latency, that comes under the URLLC, where only end-to-end latency required is 1 millisecond. Okay, for IMT 2020, there are 8 capability requirements. That is the vision requirement that is set by ITU, right? The first one is the peak throughput. The minimum peak throughput should be in downlink is the 20 gigabits per second, and uplink is the 10 gigabits per second. That is the peak throughput, right? When all the resources of the G node be provided to the single user, that means 20 gigabits per second in the downlink. And average, or you can say minimum user perceived rate should be 100 Mbps. That is the requirement only, not that is set by the ITU. The spectral efficiency. What is the spectral efficiency? Spectral efficiency is the bits per second per hertz. How many throughput or bits per second you can send in the spectrum? You can say per hertz, right? That should be 3 times more than the 4G, fourth generation communication, or you can say IMT advanced. That is the blue color, na? Shaded blue color you can see here. These are the IMT advanced requirement, right? From that is the 3 times means that is the comparison from 4G to 5G. There should be 3 times more spectral efficiency from 4G in 5G communication, right? The mobility, that means if your vehicle or your device is moving up to 500 kilometer per hour, the services or seamless service should be there of 5G network. That is the minimum requirement. That is the 500 kilometer per hour device or service supported in the 5G network. Air interface latency not, it is the 1 millisecond. Okay, target, it is the end-to-end latency is the 1 millisecond. Connection density, I have already told, 1 million devices per kilometer square. And network energy efficiency, that is the 100 times more than the 4th generation technology. And last one is the requirement of 5G is the area capacity. Area capacity means 10 megabits per meter square. Why area capacity comes in your 4th generation, 3rd generation? There is the cell capacity is there, mainly the KPI is the cell capacity, right? Here is the area capacity, because your base station is not a standalone base station. Your radio networks comes in the cloud, where a pool of BBU is there, right? So that no clear cut boundary between the cells. That's why the area capacity is specified, or KPI is given in the 5th generation communication, right? This slide is clear to all of you?
Yes, sir.
Okay.
Yes, sir.
These are the different, I have already told, na? EMBB, URLLC, and MMTC. EMBB means your high speed throughput, enhanced mobile broadband. URLLC means high reliability and low latency. And massive connectivity means a large number of connections that's supported by base station. That means 1 million devices per kilometer square. Okay. The different types of applications comes under these 3 main domain that is specified by 3GPP. Okay, EMBB, under EMBB, not only these 3, but many more use cases will be there in future, right? AR, VR, augmented reality and virtual reality, live sports, 360-degree view, or you in the live sports, okay, and 3D and 8K high HD video supported by this EMBB use cases. URLLC, the smart manufacturing, okay, autonomous driving, unmanned aerial vehicle, that is the example of URLLC, okay, and remote surgery. Remote surgery is also example of URLLC. And massive machine types of communications, that is the MMTC. MMTC means massive. Massive means a large number of devices that would be connected to network. That is a smart city application of this MMTC types of services. The small use cases, the smart city, okay, internet of vehicle, smart home, where large number of sensor and devices to be connected with 5G network. Okay, so different types of scenarios there, different types of use cases there. All the use cases or variety of use cases are supported in 5G network. Okay, these are the some use cases, same use more highlighted in the use cases. The first one is the virtual reality. You can see here, everything you see is virtual. VR headset, the boy is wearing the VR headset, okay, and by using this VR headset, they are everything he sees is the virtual world. He goes into the virtual world by using this headset. Okay, this requires virtual reality requires very high throughput, 10 gigabits or 1 gigabit, 5 gigabits per second throughput, and low, also 10 millisecond latency. Augmented reality means information screen is superimposed on the real life environment. That is the mix of both, not only virtual. The VR is the fully virtual, but augmented reality is the application of virtual plus real. Right? You can see different types of information you can impose on the real world. That is third one is the mixed reality. Mixed reality means in there is the interaction with real and virtual object that is enabled. Interaction is not there in the real and virtual world here in the AR, but interaction is there in the mixed reality. Like you can see some of the car design. This is the virtual car is shown here, right? And they are real people's all these slides are visible to you. Cloud VR requires 5G high. Yeah. Visible to all, na?
Yes, sir. Yes, sir.
Okay. So cloud VR, now all the VR, virtual reality, augmented reality goes into the cloud. And what are the advantage of cloud actually? Cloud means your only the thin client is there. Suppose your VR, AR, okay. VR, AR means virtual reality and augmented reality. Your fully bulky headset, okay, turns into the thin terminal. Why thin terminal? Because all the memory, everything goes into the cloud. Okay. The cloud AR VR requires very low latency and high data. The cloud, all the cloud applications actually requires 5G network. In the future 5G, okay, all the cloud applications like written here in the right hand side, cloud gaming, cloud computer, cloud VR, cloud AR, cloud MR. Computer means all your memory, your processor, they need not to buy at your home. Okay, just you pay what you are using, you just pay to the cloud service provider. But just you have to a thin client terminal you have, and with this connected with the your 5G network. Because cloud, all the cloud application requires very high throughput and also a very low latency. So all these cloud applications will be fully compatible only with the 5G network. It will not compatible with the 4G or 3G network. Okay. The low cost, lightweight, and mobility is there in all the cloud gaming, cloud computer, and cloud VR AR. Because your cost is also involved. Now, low cost attract more and more customers, and these all cloud applications. And the future is always goes into the cloud. All the applications comes in the cloud. This chart actually shows the different applications, which applications require high bandwidth or high throughput, and which applications require low latency, and which application requires high latency. The one box is written here, na? Like your AR, VR requires, you can see a 10 millisecond latency and 1 gigabits minimum throughput requires. Okay. An unmanned aerial vehicle requires latency. Autonomous driving, human robot collaboration, remote surgery require less than 1 millisecond, or you can say 1 millisecond latency. And throughput is the 300 Mbps, 50 Mbps autonomous drive. So these charts only shows the which application require how much minimum throughput and minimum latency. Okay, it's like your smart wearable and mobile broadcast does not need much more latency, na? The latency is higher in the x-axis direction, and throughput is higher in the y-axis direction. The different applications are plotted in this x-axis and y-axis plot. Okay. Autonomous driving requires a low latency, na? Autonomous driving latency and added distance is there. Latency, 3G latency is normally 100 millisecond, and 4G latency is the 50 millisecond, and 5G is the 1 millisecond. When your driving speed 100 kilometer per hour. Okay, when your autonomous driverless car is there moving on the road, it requires very low latency. Why? Because you can see in 3G, if you are using the 3G connectivity, then your braking distance is the 333 centimeter. That means when your brake applied on the car, it stops. It takes the distance to stop the car, that is the 333 centimeter. In 4G, it is a 167 centimeter, but in 5G, it only 3.3 centimeter. That is the braking distance. So 3G, 4G, all are the dangerous for the autonomous driving. Okay, 5G is a true sense for the autonomous driving, because braking distance is very low. You can calculate this braking distance when you speed, and also you can take the speed of light, right? You can calculate this distance, 3G, 4G, and 5G braking distance. Emergence of IoT, all of you know the Internet of Things, emergence of Internet of Things technology. Actually, basically two domain of 3GPP, 5G use cases, that is the MMTC and URLLC, are the part of Internet of Things. Main is the MMTC is the part of Internet of Things that requires a large number of connection per square kilometer. Okay, these are the gap between 4G and 5G. Okay, the latency 30 to 50 times reduced in the 5G communication. Throughput is 100 times increase in the fifth generation from 4G to 5G. Connection density is approximately 10,000 per kilometer square. That is not exact, but approximate. And in your 5G, 1 million connection per kilometer square is achieved. And network architecture is 4G is not very flexible, but 5G is flexible because of virtualized core network, virtualized RAN network. Okay, and what is virtualization? Can anyone tell me the example of virtualization? Your mobile phone, na? Your mobile phone, your third generation on second generation, your keypad comes as a physical keypad, na? 1 2 3 A B C D. You have to type many times, na? When you A B C, okay, that is the physical keyboard. Now virtualized keyboard means one chat box. Okay, virtualized keyboard means your smartphone keyboard. Nowadays you are using the 5 7 6 inch screen guard and your touchpad, your keypad is now virtualized. Previously the physical keyboard is there in your phone, but nowadays it is a virtualized keyboard. You can change the size of keyboard, na? When you want, it is keyboard is appear. When you don't want it will disappear. You can change the size, you can change the language of keyboard. Okay. Different types of flexibility comes under this by this virtualization tech. And some of the NFV and SDN is the technology that is written here, by which you can achieve the virtualization of your 5G core network or radio access network. Right? Now again, one question is there: which types of 5G applications scenarios are defined by ITU? Enhanced mobile broadband, ultra reliable and low latency communication, massive machine types of communication, and narrowband IoT. Which options are correct? In this question, actually more than one choice is correct, not only single choice. More than one choice is there. Am I audible to all, na?
Yes, sir.
Which options are correct in this question? A, B, C, all the three you already discussed, na? Enhanced mobile broadband, URLLC, and MMTC. These types of 5G application scenarios are defined by ITU, na? In June 2015. That is the, I have already shown you the triangle where these three vertices are shown by this AMBB, URLLC, and MMTC. So all the A, B, C, all the three options are correct. Not specific, are given in the ITUR in 2015. Narrowband IoT is a specification of 3GPP release 13. Okay. Okay, PPT is still on. Why these are happening, na? Now this PPT is quiz, which types of 5G applications? Now slide is changing or not after quiz? These are the
Yes, sir.
okay. So now you can see the question, na? See the quiz, which types of 5G application scenario are defined by ITU, right? Option A, option B, option C, all these three options are correct. Clear? Now this slide is okay, na? Okay, after that,
Yes, sir.
this slide is which contains 5G standardization progress. I will skip this. These are the different 3GPP releases. Okay, these are the different 3GPP releases. These are the evolution actually. 3GPP evolution of the mobile network. The 5G evolution starts from 3GPP release 15, release 16, and release 17. Okay, and this release 12, 13, 14, all these three is the evolution of 4G network, 4G evolution. Okay, so two parallel track is there. 5G starts from release 15, and also the 4G also starts evolving. Not evolution is stopped here in release 14, but it is also evolving. Some of the features of narrowband IoT features and other features are evolving in different releases. Okay. Other than this 4G evolution, different track starts of 5G and R, that is 3GPP release 15. These are the different specification actually by 3GPP given for 5G network. Okay, the 5G NR means 5G new radio. That is the name of radio access network of 5G. Okay, and 5G next generation core means 5G core network, and EPC means evolved packet core. That is the name of 4G core. Okay, and LTE advanced is the 4G network, and LTE advanced pro means that is the 13, and release 13 and release 14 is known as the LTE advanced pro. Okay, and release 12 and before release 12 is 11 and 10 is known as the LTE advanced, and LTE is a 3GPP release 8. So different specification is there. Okay, for different. And what is the first evolution of 3G network? That is the release 99. After 99, it comes as a release 4, then release 5, then release 6, release 7, release 8, release 9. That numbers starts growing. Release 8, 9, 10, 11, 12, 13. From 12 here, written here 12, 13, 14, because here we are showing only for 5G evolution. Standards start from which releases, that's why here only release 15, 16, and 17 are highlighted. Okay. These are, I have already told, NSA, NSA. Okay. NSA, say non-standalone option and standalone option, where NSA means you have core with 4G, but access network having both 4G and 5G. That is the NSA. SA means your core as well as your radio access network. Both are 5G base station as well as core network. Okay, these are the different evolution, actually standard evolution, how 3GPP release 15, when it starts, standard version, standard formulations, and okay, different types of test and verification is there. Okay, then after terminal test and interoperability test, and the next 3GPP release starts evolving. The different steps in there within the one release. Okay, that is written here. Some of the 3GPP. Yes, please.
सर आज
Slide
इतना
is
ही
visible.
पढ़ेंगे।
आज इतना ही पढ़ा है?
Yes, sir.
Okay. Just I will give a brief. I will not go into detail, na? Okay. Just you can one quiz, then I will finish. Since which 3GPP version is 5G introduced?
R15.
R15, correct answer. The from release 15, the 5G introduced, 3GPP version of 5G is introduced in release 15. Okay, for the on from release 15 and release 16, now currently release 17 is going to be specified, maybe second quarter of 2022. Okay. So now, okay, should I stop here or any question you have? If you have any questions, or should I stop
No,
here?
sir.
No question?
No, sir.
Okay. I have given just a general description of 1G, 2G, 3G. Okay. Detail of separate classes for second generation, separate classes for third generation and fourth generations will be taken by the faculty in future. Okay. So
Okay,
now
sir.
I will stop here. Okay. Thank you. Thank you to all.
Thank you, sir.